All right, in the last couple of videos, we've been solving quadratic equations where we were instructed which technique to use, right? In problem 1, we were told to use a square root. In problem 3, we were told to complete the square. And in this last video, question 4, we were told to use the quadratic formula. Okay, so if we encounter a quadratic equation and we're not instructed which technique to use, how can we do this in the simplest way possible? Well, first thing I'd recommend is just to look to see if your variable only appears in a square term. Okay, so if you have an equation like one of these you see here in green, okay, in each instance, the variable x appears only in a square term, whereas in equations like this that you see here in purple, see I have a square term here, but then I also have this linear term. And likewise here, x appears in this square term, but it also appears over here. Okay, now if we are in the case where the variable is only showing up in a square term, then we can isolate the square term if it's not already isolated, and then use a square root. Okay, I think that's going to be the easiest way to tackle something like that. Now, if we're in this kind of territory with these equations you see over here in purple, then what we want to do is move everything to one side and write the equation in the standard form. So ax squared plus bx plus c is 0. And then if this trinomial factors, then factor it and you find your solutions that way, right? It's pretty straightforward from there. However, sometimes it's hard to spot a factorization, and in other instances, the resulting trinomial just doesn't factor at all. So if that's the case, then go ahead and use the quadratic formula. All right, so let's go ahead now and look at problem 5 on the worksheet. To solve each equation using the quadratic formula only if necessary. Okay, so we'll start here with a 7 plus the quantity x minus 173 squared, and then that's all equal to 8. So here I really don't want to multiply out x minus 173 squared, okay, because that's going to produce some rather large numbers. But since x only shows up in the square term, I'm going to go ahead then and just isolate the square term. So subtract 7 from both sides, and that's giving us x minus 173 quantity squared, and that's equal to 1. And now take square root of both sides. Plus or minus over there. So we have x minus 173 is equal to plus or minus 1. Adding 173 then to both sides, we're effectively done. All right, so we have 173 plus or minus 1, and so for the plus sign, we get that x is 173 plus 1, which is 174. And then for the minus sign, x is 173 minus 1, which is 172. So there are the solutions. And that is a heck of a lot easier than multiplying out x minus 173 quantity squared. Okay, moving on to b, we have 3x minus 1 is equal to x squared. So here x shows up in the square term on the right, but then it also shows up in this linear term on the left. And so for that reason, let's move everything to one side. And I like the coefficient of x squared to be positive. So I'll subtract 3x and add 1 from both sides, or to both sides. And so that's going to give us a 0 on the left. And then we have x squared minus 3x plus 1 on the right. And this trinomial unfortunately doesn't factor because I need two numbers that'll multiply to give me the 1, and then we'll add to negative 3, and that's not going to happen. That's all right. Just use the quadratic formula. Okay, so A is 1, B is -3, and our c is 1. All right, so quadratic formula then gives us that x is the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. All right, so go ahead and punch in these values, and then we are going to just clean up, and then we're going to be done. All right, so inside the radical, what do we have here? That's going to give us a 9 minus 3 squared, and then this is minus 4, so that's 5 there. So when all is said and done, we get x is equal to opposite of -3, so that's positive 3, plus or minus the square root of 5, and then we're dividing all of that by 2. Square root of 5 doesn't simplify, so we're done right here. All right, part C, x squared is equal to 4x plus 5. Again, x shows up in this squared term on the left and in the linear term on the right. So let's go ahead and move everything to one side. So I'm going to subtract 4x and 5 from both sides. So we have x squared minus 4x minus 5 is 0. And now this trinomial does factor. So I'll go ahead and factor it. It factors as x minus 5 times x plus 1. And now we just set each factor to 0 because this product is equal to 0. And so we'll get x equals 5 and -1 for our solutions. All right. That's not to say the quadratic formula would not work here. Okay, you certainly could apply it. It's just that I think factoring is going to get you there a lot quicker. Okay, moving on to D, 8x minus x squared is equal to 0. All right, well here I have everything to one side, and x does show up in both a square term and a linear term, but I also notice there's a common factor of x here. So I'm just going to start by factoring it out. And see, now I'm basically done because with this factorization now, either x is 0 or 8 minus x is 0. So I get the solutions 0 and 8, and that does it. All right, cool. So now let's go ahead and look at these last couple. E, 2x squared minus 3 is equal to 47. Well, x only shows up in a squared term here, so I'm going to isolate the squared term, add 3 to start. So we have 2x squared is equal to 50. We can then divide both sides by 2. And that gives us x squared is equal to 25. And then to finish, let's go ahead and take the square root of both sides. And so we have x is equal to plus or minus 5. All right, not bad. Now f, we have 700 plus 100x minus 100x squared is equal to 100. All right, well, everything, right, has a factor of 100 in it, right? You have this 700, 100, 100, right? So I'm going to start by just dividing both sides of the equation by, in this case, minus 100. I could divide by 100, but the nice thing about dividing by negative 100 is that that's going to give me a positive coefficient for x squared. Okay, so doing this will give us positive x squared. Then here I'm going to get minus 1x, so just minus x. And then here I have minus 7. And then on the right, I'm dividing by negative 100, and that's giving us negative 1. Okay, that's a heck of a lot simpler. So now I'm going to add the 1 to both sides. And we get x squared minus x, and this is negative 6 there, and that's 0, and this fortunately factors. Okay, it factors as x minus 3 times x plus 2. And so now we can just set each factor to 0. This is going to give us 3. And the second factor is going to give us the solution negative 2. All right. Nice. And then lastly, g, 10 plus 2x squared is 8x. All right. Here I see that everything has a factor of 2 in it. So I'm going to start out by dividing both sides by 2. And so that's going to give us 5 plus x squared, and that's equal to 4x. And then I'm going to go ahead and subtract 4x from both sides. So I have everything on the left side, and I'm going to write this in descending order. So x squared minus 4x plus 5 is 0, and this, let's see, does that factor? Unfortunately, no, it doesn't. I was, first glance, jumping right in, right? But we'd either need a negative 1 times a negative 5, and those aren't going to add up to negative 4, or a positive 1 and a positive 5, and those don't add up to negative 4. So we do need to use quadratic formula here. So our A is 1, our B is negative 4, and then our C is 5. Okay, so let's go ahead and use quadratic formula. We can do that over here. So we have that x is the opposite of b plus or minus the square root b squared minus 4 times a times c, all divided by 2a. So go ahead and punch in those values. B goes there and there. A goes here and here. And there is our C right there. Okay, so now we just got to clean up this resulting expression. So let's see here, we got 16 from this, and then this is minus 20. So this is negative 4. So we're actually going to have a negative under the radical. So we have the opposite of negative 4, so that's 4 plus or minus the square root of negative 4. And then we're dividing all of that by 2 times 1, which is 2. All right, so now let's go ahead and rewrite the radical. So this is 4 plus or minus. And now the square root of 4 is 2, and the square root of negative 1 is by definition I, so this is 2I. And then again, we're dividing all of that by 2. And now I'm just going to split this up into 2 fractions as such. And so now for our solutions, we have 4 over 2 is 2, and this is then plus or minus 2i divided by 2. The 2's divide out, and I'm just left with an I. All right, so we wind up with these 2 solutions. All right, and that's going to do it. Thanks so much.